Hey folks, Mr. Dell here. Hey, we are looking at what is a function and what's not a function, given just the graph of these um, relationships. So we have these are problems that I'm pulling from CPM's course 3, and this is section 9.1.1. Okay, so the directions say determine whether the graphs below are functions or not functions. Explain your reasoning. So just again, the definition of a function, right? To be a function, every input has exactly one output. Okay, so every input has exactly one output. That being said, for every x, so every x has exactly one y, right? So that makes it a, not the other direction, sorry, it goes this way. Every x has exactly one y. That's what makes it a function. Only one y, only one input. My input being my x, so every x has exactly and only one y. That's how we know if it's a function. So if I'm going to go through and let's look at what is a function and what's not a function, and we can use those pictures to help solidify this definition. A function, every input has exactly one output, only one output. Okay. So if I look at my graph here, here's all my x's, and if I think about every one of these x value on my x, on every x, if I think of all of the values of this segment here, every one of the x's only has one y, right? These are all unique points, and that x only has one y, right? Wherever this x is, if that x is 3, has a y of 1. Or if x here being 1 has a y of 2, or whatever those values are on that. So this is a function. So yes, okay, this one is a function. But then if I look at B and I look at these points, I have, let's say here at x equals 4, you notice the graph has a point here where x is 4 and y is 1, we'll say, I'm approximating. But then down here as well, this also would be a point on the graph on this relationship, and it also has an x of 4, but this time a y of -3. So we have a relationship that has that not every input has exactly one output. This input of x has actually two outputs, a 1 and -3. So that being said, this is not a function. Okay, this relationship is not a function because the input of 4 has more than one output instead of exactly one output. So far, so good. Okay. If I look at this, is just basically it looks like we just have 4 points, right? And if I want to define where these 4 points are, this point here, right there, would be at, looks like -2, +2. This point here looks like it's at -1, -1. But then we go down to here, and also this point here would also be at -2 for the x and -4 for the y. So right there, I see we again fail this definition of every input has exactly one output, because this x value, the x value of -2, exists at +2, but it also exists here down at -4. So once again, this is not a function because it fails this requirement. To be a function, every input has exactly one output. One way to also think about this is what we call the vertical line test. Okay. The vertical line test is meaning if I could draw a vertical line, vertical lines are up and down, right? And only hit the hit the graph once every time. So every time I would draw a vertical line, let's show it here on A since we already did A. Every vertical, like exactly vertical, all my vertical lines, if I keep drawing vertical lines, I'm only hitting the graph one time. I'm intersecting the actual relationship once. And so therefore it is a function. It passes the vertical line test. If I drew a vertical line here, it hits that point and that point, right? So drawing a vertical line, it actually goes through the graph more than once. So therefore, that's why it fails it. So that's this vertical line test. Here, if I drew a vertical line, I would have hit that point and that point with that same vertical line. So therefore, again, fails the vertical line test. So it's D. So D, does D pass the vertical line test? If I draw a vertical line everywhere along this graph, I'm only ever hitting the actual graph itself once. And so, yes, every input, every X value only has one output. So this one right here is also, yes, it is a function. C or E. So E, if you look, you've got a part of the graph going this way and another part of the graph that way. So once again, if I draw a vertical line, all these vertical lines that I'm drawing here are hitting the graph twice, right? Once there and once there. So that being said, it fails the vertical line test. Each of these X's have more than one Y value because that point has the same X, different Y, same X, different Y. So this one is not a function. Last one. Looks like it's that point, that point, and that point, just 3 points. And again, none of them hit the same vertical line on a vertical line test. They each have unique X and Y's, right? That X has a Y of 1. That X has a Y of 2. That X has a Y of -2, right? There's no same X that has more than one Y value. So this is, yes, a function. Okay. So there you have it.